Okay, this is section 14.4, and we're covering two problems, 25 and 27. 25 says, which are invariant under a half turn? Distance, angle, measure, area, and orientation. Well, a half turn is a rotation. The notation is R, O, comma, 180. And we remember that a rotation is an isometry. So because a rotation is isometry, we know it preserves distance and angle measure, as well as area. The orientation is preserved. I'm not going to get into this too much. I'm going to say that a reflection doesn't preserve orientation, but a rotation definitely preserves orientation. Okay, clockwise stays clockwise, counterclockwise stays counterclockwise. You know, you can check it out by doing a few problems like that, but I won't get into the math of that. 27 is kind of an interesting problem. They give you this figure here, and this is a triangle. This point right here is at the origin. A is 4, 0, B is 1, 3. All right, and what we have to do is we have to rotate it 90 degrees counterclockwise. So, you know, this is the general rule for doing a rotation. It takes a point x, y, that's the pre-image, and it maps it to the point negative y, x. So just algebraically, we can see that point A, 4, 0, goes to the image of A prime, and that's 0, 4. Okay? B, 1, 3, goes to the image of B. The y becomes the new x with a negative sign, so negative 3, and then the x becomes the new y, 1. They just change places. And then if you have a point that is exactly at the center of the rotation, it doesn't go anywhere. So my point at the origin stays at the origin, so the pre-image and the image are the same. All right? So that's that. So when I plan them, when I graph them, you can see that this thing gets rotated up. It gets rotated a half turn like this, kind of complete with sound effects there. All right, so that's that. Okay, done.